So, we will continue our discussion on IC engine, and today we will discuss about engine operating characteristics and related issues, that is mean effective pressure, various efficiency term, air fuel ratio, specific fuel consumption, etc. Before I go to discuss about engine operating characteristics, I would like to discuss a few important points that we could not complete in my last lecture, that is the engine classifications. I mean based on the cylinder arrangement. This is very important, that we have discussed so far that IC engine can be classified based on the type of ignition or type of combustion, whatever it is, SI engine and CI engine, and then number of strokes, that is 4-stroke engine, 2-stroke engine. We have discussed in detail about what are the different strokes in a 4-stroke engine. We have identified that in a 4-stroke engine we had 1 power stroke versus 3 idle strokes. On the other hand, in a 2-stroke engine only we had 2 strokes, I mean one is power stroke and another is compression. But while power stroke is occurring, we can have inlet and exhaust simultaneously, and for that we need not to have 2 different strokes separately. So, to continue with that, today I will discuss about that engine can be further classified based on the arrangement of cylinder, that is based on the position of the piston. So, I will just write that types of engine, that is what we have discussed, types of engine. It is very important that we have discussed 4-stroke, 2-stroke, spark ignition and compression ignition, but today I will discuss that the engine can be classified according to the position of the piston. So, apart from those, I mean 4-stroke, 2-stroke, based on the types of ignition and based on the number of strokes and based on the types of ignition, that is SI and CI, we have discussed, but today I will discuss about that engine can be classified according to position of the piston. This is very important, that according to the position of the piston engine can be classified. So, here while we are talking about that, if we can classify engine based on the position of the piston, this criterion is based on the arrangement of the engine cylinders. Essentially this criterion is based on the arrangement of engine cylinder, right. So, this is very important that we can classify engine based on the position of the piston, that this criterion is based on the arrangement of cylinders. So, I will discuss one by one. Number 1 is very important, most common type is inline arrangement. Most common type is inline arrangement, that is cylinder placed in a line. Here cylinders are placed in a line. So, this is known as inline arrangement, which is most common type, and I will draw the schematic also. There will be a common shaft. So, last class I have discussed that, so we have a common shaft and this is rotating, maybe we will be having one flywheel and so this is most common type inline arrangement, that all cylinders are placed in a line, and we have discussed that if it is a multi-cylinder engine, then only to reduce the power fluctuation, I mean arrangement is done in such a way that maybe when power stroke is occurring in one cylinder, there might be there has to be ideal strokes in other cylinders. So, in that way you can redistribute power and power fluctuation can be minimized. and this common shaft is connected with the flywheel. So, this is flywheel. So, if I this is inline arrangement, and the if I draw again a schematic, suppose so these are the cylinders, these are the cylinders, and this supply power to a common crankshaft. This is a shaft which is connected to the common crankshaft. So, this supply power to a common crankshaft. So, this is most common type inline arrangement. Next we will discuss about that another arrangement which is two, I mean is also very important, that is opposed cylinder type. There might be a arrangement based on the opposed piston or cylinder type. Based on the position of the piston, criterion is essentially based on the arrangement of the engine cylinders. So, opposed cylinder type, this is very important, that again I have to draw the schematic. So, here this is opposed cylinder type, that is cylinders are opposing each other, cylinder faces are opposing each other. Now, specification is that here we have only one common crank shaft. So, this is known as opposed cylinder type, only we have one common crankshaft, and both the cylinders are arranged in such a way that they are opposing each other, but we can run both the cylinders at a time. So, this is opposed cylinder type. Similarly, we have opposed piston type. So, number 3 is again I am writing opposed piston type. So, now we have seen that cylinders are placed in such a way that their faces are opposing each other. Now, we might have another arrangement where pistons might face pistons are opposite to each other. So, arrangement is like this, I am drawing again. If it is a SI engine, I am not going to discuss about spark plug or fuel injector, because it depends upon the types of ignition we required, because if it is SI engine we should have spark plug and carburetor, but if it is CI engine, instead of spark plug we should have fuel injector, and we can take air through air intake manifold. So, so this is maybe these are the piston. So, So, these are two pistons, you know, this is opposed piston type, and both are executing power and exhaust stroke at same time, two crankshaft. So, here we have two crankshaft and both are executing, I mean both are executing power and exhaust strokes at same time. So, this is very important, that here we have two crankshaft, both are executing power and exhaust stroke at same time. This is called opposed piston type, these pistons are opposing each other, but power and exhaust will be at the same time. Next is another important type is I will discuss that, known as radial type, radial engine. So, this is very important, radial engine. So, radial engine is like this. I have to draw again the schematic, I mean schematically I have to draw what is radial engine. I will draw now. So, and so this is the crank and it is rotating in this direction. So, we have a multi cylinder common crank, this AB is the common crank. So, we have seen that we have common shaft, this is common crank, you know all engines are connected to this common crank and connecting rod, and this is suitable, we have multi cylinders, this is suitable for, this is suitable, rather I can write used mostly in early aero engines. So, this is radial engines used mostly in early aero engines. So, this is radial engine. So, we have discussed that based on the cylinder arrangement, rather position of the piston, we can classify engine into different categories. We have discussed that most common type is inline arrangement, where you know cylinders are connected in a line and supply power to a common crankshaft. Then we have seen opposed piston type, opposed cylinder type, where cylinders faces are opposing each other and one common crankshaft. Opposed piston type, we do not have common crankshaft, we have two crankshaft, but both are executing power and exhaust stroke at a time. And lastly, radial engine, where you know radial engines very important, rather it is used mostly in earlier radial engine, where we have multi cylinders and we have only one common crank AB. So, with this we have seen that apart from the classification based on the types of ignition and number of strokes, we can classify engine based on the arrangement of cylinder, that rather position of the piston. So, with this we now move to see another important is types of cooling which is used in a IC engine. As I said you that probably I will discuss in detail about this, but as I said that in a IC engine, in internal combustion engine, whenever combustion is taking place, idea is to essentially to use in case of a SI engine we are normally having one spark plug which ignites the fuel. On the other hand, in case of a CI engine we are utilizing the high pressure temperature of the air at the end of the compression to ignite the fuel without having any external agent. Fine. So, the ultimate objective is to that we have one power stroke where we had 3 idle strokes in a 4 stroke engine or 2 another 1 idle strokes in 2 stroke engine, and we have discussed about that having 3 idle strokes versus 1 power stroke. I mean what is the what are the advantages rather, but power stroke, that means the stroke from where we are getting energy. Out of these 4 strokes, only power strokes we are getting energy, and for other 3 remaining strokes we need to supply energy from the flywheel. That is whenever we are getting energy from the power stroke, the energy is remaining stored in a flywheel. We need to run engine, we need to run vehicle. So, of course, a part of the energy will be utilized to rotate a wheel, rather a portion of the energy will be stored in the flywheel because you need to borrow energy for occurring 3 other different strokes. But whenever we are having power stroke, that means we had combustion, and because of the combustion we have high pressure and temperature, and that will create a thrust on the piston face, and that is what we have a power stroke. Whenever we are having high pressure and temperature in the inside the cylinder, of course, engine cylinder walls of the cylinder, piston face will be heated. Now, we need to reduce, because maybe we cannot reduce temperature to a severe extent, otherwise efficiency will drop. On the other hand, we have to have a cooling system, so that we need to we need to make sure that the temperature should not go beyond the limit for which maybe lubrication system and will burnt off, and also there won't be any thermal crack in the cylinder wall or the piston face. Anyway, so there is a very judicial choice, because we should not have too much of cooling, otherwise temperature will reduce in such extent that it will drop down the efficiency of the engine. On the other hand, we should not allow we should not allow that temperature should go beyond a limit, otherwise there will be a problem. That is what we have discussed. So, whatever engine it is, SI engine or CI engine, normally in internal combustion engine we need to cool down. So, we have seen that IC engine, internal combustion engine, broadly SI and CI which we talk about, because whether it is defined, whether it is classified based on the number of strokes or different position of the piston, but spark ignition engine and compression ignition engine, for both the cases we need to cool down, because in both the cases we have combustion, we should have, we will have combustion, and because of the combustion there will be a huge pressure rise. To reduce the pressure and temperature we should have proper cooling system. So, that is why both the engines, are required to cool as they are heated during their combustion process, as they are heated during combustion process. So, this is very important, we need to cool down. Now, question is, we cannot, this is very important, but we need to make sure that it is not required to cool the engine completely, because efficiency or the power output from the engine will be decreasing. So, it is not required. It is not required to cool the engine completely. Otherwise efficiency, rather power output from the engine will drop. So, because very important, because we know that mass m dot is equal to rho I into Vs, that is swept volume, mass flow rate. So, this is mass flow rate and this is swept volume. Since this rho I can write Pi by RTi into Vs. So, if Ti drops, so now if Ti drops, then what will happen? So, I mean mass flow rate of coolant will increase through the engine cylinder, and as a result, although swept volume is remaining same, if Ti reduces, then mass flow rate of coolant, that will increase. So, it will create again to have higher heat transfer, that is not a desirable one. So, we need to take a judicial choice that what will be the amount of temperature we need to reduce from the engine cylinder, that is very important. So, temperature should not be, if it drops drastically, then mass flow rate will increase, and because as I said you that since coolant, this is swept volume, Vs is swept volume is remaining same. So, what will happen that efficiency, rather power output will drop. So, I am writing that heat generated by IC engine due to burning of fuel 30% transfer by the engine. So, whatever amount of heat generated in IC engine, so heat generated, whatever amount of heat generated because of the combustion, heat generated because of combustion, here 30% of heat is transformed by the transferred by the engine, transformed by the engine due to because heat generated because of combustion, or rather I can write due to burning of fuel, that is combustion, due to burning of fuel, we will discuss. So, 30% of heat is transformed by the engine, and 30 to 30% has to be removed by cooling system, and remainder by exhaust and lubrication system. So, 30% of heat is transformed by the engine, 30 to 35% is needed to be remove, or is needed to be removed by the cooling system, while remaining heat is removed by the exhaust and lubrication system. Exhaust and lubrication system. So, this is very important that 30% of heat is transformed by the engine, 30 to 30% heat we need to be we need to transfer by cooling system, while remaining heat is removed by exhaust and lubrication system. This is very important. Now, an engine that is not cooled, what will happen? Whenever we are having engine, no matter whether it is SI or CI, so if we do not cool the engine, this is very important, if we do not cool the engine, then what will happen? So, an engine that is not cooled will soon reach a temperature which will seriously harm its functioning. So, that means an engine that is not cooled, right, will soon, so we need to cool simultaneously, so we will reach a temperature that which will seriously harm this temperature will seriously affect, rather harm the functioning of the engine. So, an engine we need to cool. If we do not cool it, it will reach a temperature, will sooner reach a temperature which will seriously harm the functioning of the engine. This is functioning of the engine. How? On the other hand, this is very important. Again, that is what I said, that again, if the heat is too much, then again, if heat is transferred by the lubrication system, by the cooling system, heat is transferred by the cooling system to a severe extent, then temperature and efficiency, and so is the efficiency, temperature and so is the efficiency of engine drops, then temperature or so is the efficiency of the engine will drop. So, this is very important. So, out of these two we need to make sure that we will have a proper amount of heat needs to be transferred from the engine cylinder, and that is what we need to have a design calculation. Anyway, so as I said is that if a engine that is not cool will reach soon a temperature, we will soon reach a temperature which will seriously harm the functioning of the engine. So, which will soon reach a temperature which will affect the or seriously harm the functioning. How by how is very important, because if heat is now, if I come to the first point, by how, there are many other points. I am writing first, if temperature is so high, if temperature is very high, if temperature is very high, I mean this is beyond the tolerance level of the cylinder material or something else, then what will happen? Lubrication will be burnt off and resulting lubrication system, this is very important, lubrication system will be burnt up, and it results, this lubrication system will results what? Scoring of cylinder, blinding of piston bearings and wrapping of valves. So, SCO, scoring of cylinder, right, then known as wrapping of valves or any other mechanical trouble. So, and that is known as of pistons and bearing. So, I am writing rather it will scoring of cylinders, and that is very important, that of valves, and will create other mechanical trouble, So, if temperature is very high, lubrication system will burnt off and it will eventually result in this other problems like scoring of cylinder, wrapping of valves and other mechanical trouble. Other piston and bearing will be, and also damage of piston and bearing. These are the problem. So, we need a cooling system to keep the engine from getting so hot as to cause these difficulties, and yet permit to soon the engine to ensure maximum efficiency. So, considering this, we need to cool down the engine so that the engine temperature should not be hot enough. So, and eventually we will get this kind of difficulties, but at the same time we need to be very cautious so that the temperature should not be transformed for the engine to a severe extent, otherwise temperature and it ultimate effects on the efficiency of the engine will drop down. So, now question is, so we have seen that we need to have cooling. Now types of coolings is very two types of cooling system is normally two types of cooling. One is air cooling, another is water cooling or liquid cooling, not water or liquid cooling. So air cooling, you know that since we know that heat transfer rate is proportional to the area, you know, so we need to increase area. So this area is increased by increasing, by providing fin. We have seen in heat transfer by providing extended surface like fins, etc. Now how we can get air, because you know that the forward motion of the engine cylinder itself allows the air to suck in the engine, and if we have a proper path, rather if we can direct that incoming air through proper path, so that it can be, you know, ultimately taken to the engine cylinder, and by providing fin surface we can eliminate heat, because it proportionally depend upon the area. Now another important is cooling, or sometimes apart from this, you know, forward motion of the engine itself allows the air to come in, but on the other hand sometimes a blower is provided. Sometimes a blower is used to increase the rate of which air is increased. The blower is used to increase the mass flow rate of air. Very important. So when we talk about area is increased by surface area, so number one is, this is number two, number one is forward motion of the engine, forward motion of the engine itself, you know, allow the air to come inside the engine, or in sometimes we need to increase the mass flow rate, then we can use blower. On the other hand, we talk about liquid cooling. So air cooling is fine. So we should ensure that whenever we are having engine movement, that forward movement itself will allow the, you know, liquid to air to come in, and we can supply air by blower, so that mass flow rate will increase. On the other hand, we can have liquid cooling. So normally we have seen that normally cooling water jacket is provided. Cooling water jacket is provided. So whenever having cooling water jacket, we need to supply continuous rate of water, and water should not be, you know, I mean, we can use water and that has to be recycled. I mean, whenever water is going to engine cylinder through some, you know, flow passage, and eventually when it takes heat from engine cylinder, we can reuse water. So we can take water again in some place and we can have cooling. So this is called recycling. I mean, we can recycle water. So cooling water jacket, so water from cooling water jacket is taken. So normally whenever it is going to cooling water jacket, it takes heat from the cylinder, and then from cooling water jacket, that is hot water. So cooling water jacket, water will you know, rather water will be used to, you know, take heat from cylinder, then this hot water is again this is very important, this hot water is again taken into the into the radiator, one another small device, by a centrifugal pump. This pump is driven by V-shaped, you know, V-belt pulley on it, engine by a V-belt pulley connected with the crankshaft. So, this is very important. We are taking water into a hot water cooling water jacket, water takes away heat from the cylinder, and that upon taking heat the temperature of water will be increased, and then hot water is taken again, hot water is again taken to the radiator using a centrifugal pump, and centrifugal pump is run by a V-shaped pulley which is connected to the crankshaft. Now question is, now whenever we are taking water to a radiator, that means there we need to, so very important. So in radiator water is cooled using air which is drawn in this which is drawn you know through the into the radiator either by a fan or by the airflow developed, or because of airflow developed due to forward motion of the engine. So that means we are taking hot water into the radiator, but radiator we need to cool down the water because process is very continuous. So what is done in the radiator, normally again it is heat exchanger, so we can use fan to supply water, you know, cooled air which will be supplied surroundings the radiator. So it will take the air, it will take away heat from the coolant from the water, or sometimes the airflow is developed because of the forward motion of the engine. That is what I told in case of air cooling system. So these are normally two different types of cooling used in internal combustion engine, but mind it, when you use water as a coolant, it is not always possible that we can take we can't use water always, because water you know, freezing point is very low. So what is done normally, if you even use the car in a area where temperature is very less, even minus less than 0 degree, that time we need to mix a reagent which is known as ethylene glycol with water, and which will increase the you know, freezing point, I mean so that water cannot be water won't freeze. Otherwise if water freeze, then it will there will not be cooling at all, rather the radiator and cooling water jacket, because upon, you know, freezing it volume will expand and it will try to, you know, create a crack, rather breakage of the cooling water jacket and the radiator. So with this we next move to discuss about the engine operating characteristics. Is very important, but today I will discuss a few important things, that what is the engine operating characteristics. So I will draw a schematic again, and we have identified the, suppose we have a engine cylinder, and this is top dead center and this is bottom dead center. So this is piston, and piston is connected with crank and connecting rod mechanism, and ultimately you are getting power. So I am not going to draw, because there might be a spark plug, carburetor, all those things I am not going to draw. So now question is, if I would like to draw the, you know, as I said you that there will be a change in pressure and volume whenever the piston is moving from TDC to BDC, BDC to TDC for during different strokes. Now question is, you know, that whenever piston is coming from TDC to BDC, I have discussed, we are creating a vacuum inside the piston. So suppose if it is atmospheric pressure, suppose this is the atmospheric pressure, PATM, right, and if we have two different volume, this is VBDC and VTDC. So this is VTDC and this is VBDC. So volume of the cylinder. Now whenever piston is at BDC, the volume will be this, and whenever piston is coming to TDC, volume will be like this, and so this is the swept volume. So you can see that this is the swept volume, this is VTDC and VBDC, this is the swept volume, that is VS. So this is swept volume and this is the clearance volume. Now when piston is coming from TDC to BDC, we are having a negative pressure inside the cylinder. So if I try to draw, the maybe volume is increasing but pressure will drop, I mean pressure inside the cylinder falls. So pressure will fall, and it will be like this. and again when piston is coming from BDC to TDC, that means during the compression stroke pressure will increase, volume will try to decrease, and ultimately we will get pressure will increase, and when volume will come to. So, this is, so maybe when our piston is coming to TDC at the end of the compression stroke, pressure will be high. So, pressure is high and volume reduces. The next stroke is power stroke. So, again piston will come from TDC to BDC, and at the same time again pressure will fall and but it will be again atmospheric pressure, higher than atmospheric pressure. So, pressure will fall, right. So, this will be, I mean like this. So, this movement, this is intake stroke. So, this is intake stroke, I know, this is intake, this is compression, this is power stroke, and finally this is exhaust stroke. I will discuss a few important issue. Maybe when piston is coming from BDC to TDC to BDC during intake stroke, as I said you that exhaust valve is remaining closed, intake valve opens, but exhaust valve closes not exactly when piston is departing from TDC. Exhaust valve closes when piston is little bit away from the TDC during intake stroke. So, this is very important. So, maybe intake this is the position A, that is exhaust valve closes. So, ideally whenever piston is coming from TDC to BDC, we are allowing inlet valve is open, but exhaust valve will be closed. That is what we have discussed. So, through inlet valve we are introducing air fuel mixture in case of a SI engine or only air in case of a CI engine, and exhaust valve is remaining closed. But this is not the case in a practical situation or practical scenario, because exhaust valve will start closing when piston is little bit away from the TDC, rather when piston is approaching BDC little bit away from TDC, and we are opening exhaust valve purposefully because whatever amount of fresh charge or fresh air is coming, because it is not always possible that whenever piston is coming from BDC to TDC during exhaust stroke, all the combustion product will go out. So, there might be some amount of residue that we need to expel out, and that will be expelled out using the incoming air in case of a CI engine or incoming charge in case of SI engine, and that is why when piston is coming from TDC to BDC, we do not close exhaust valve exactly when piston is at TDC, rather we close it when it is little bit away from TDC, so that inlet valve, since the inlet valve is open, so the fresh air which is coming during intake stroke will allow the residue to go out. So, I mean some portion, and doing so some portion of the air, some part of the fresh air or some part of the fresh charge will be lost through the exhaust product. That is true, but we need to we are doing like this because we need to keep open exhaust valve little bit, and so, for a small time, and by that time piston will travel from TDC towards BDC little distance, and it will and then we will close the exhaust valve. Second thing, normally when piston is coming from BDC to TDC, we should close during the compression stroke, we should close, we have discussed that when piston is exactly at the BDC, we should close, exhaust valve is closed, but we should close intake valve, but it is not the case, rather we allow an intake valve to close here. Let us say this is point B. So, this is point B, this B is intake valve close, intake valve closes. So, piston departing from BDC towards TDC, we should not close intake valve immediately, because in the previous just now we have seen that we are allowing exhaust valve to remain open up to even for a small time, even after piston is traveling from TDC towards BDC. So, some part of the charge or some part of the air will be going out with the remaining rather residue of the combustion product. So, if we do not compensate that amount of air or charge, combustion should not be efficient. So, what is done, even when piston is traveling back to TDC during compression stroke from BDC, we should not close the intake valve immediately it departs from the BDC, rather we should allow fresh charge or fresh air or charge to come in even when piston started traveling from BDC, and we will keep open intake valve for a little while, for some time. So B is the intake valve closes, that is when piston is departing from BDC, not exactly at the BDC. And then what is done, maybe we whenever piston is approaching TDC, I will discuss this issue again. So we spark plug, so maybe this is spark plug switch on, this is C. So C is spark plug switch on, right, and so combustion will takes place. So we should switch on spark plug when piston is not reached exactly at the TDC, rather little bit away from the TDC. We will discuss this issue again in detail, but for the timing you should know that at the point C we are switching on the spark plug. So combustion will take place, there will be huge pressure and temperature, and because of what piston will travel back from TDC to BDC, this is known as power stroke. So when piston is coming from TDC to BDC, what will happen? Now whenever piston, we have understood that this is a power stroke, so at the end of the power stroke piston will be at BDC, and that time inlet valve is already closed, but now we should open the exhaust valve when exactly the piston BDC, but it is not the case, rather we should open exhaust valve when piston has not reached at BDC, rather this is D. So D is exhaust valve open. So ideally piston exhaust valve should open when piston is at BDC, that is at the end of the power stroke, but this is not the case, rather we should open exhaust valve when piston has not reached at BDC at the end of the power stroke, and this is done, we will discuss, because whenever there will be huge pressure and generator, so if we, the next stroke is the after the exhaust stroke, after the power stroke, next stroke is exhaust stroke. So when exhaust stroke is happening, we are borrowing energy from the flywheel, and there will be, there will be huge pressure and temperature, there will be huge resistance. So what is done, piston is, before piston reaching at BDC at the end of the power stroke, we open the exhaust valve so that a little bit amount of combustion product will go out, and what will be the consequence in the next stroke when piston is coming from BDC to TDC, it will create less resistance because already some portion of the combustion product has gone out. So piston will face less resistance, and that is why we require less, we need to borrow less energy from the flywheel. So that is why the exhaust valve opens when piston has not reached at BDC at the end of the power stroke. Next is piston is coming from BDC to TDC, again pressure is high, and eventually piston will come to the BDC, and now when we have understood when piston exactly at the TDC, we may open intake valve again to complete the cycle, but this is not the case. We allow again intake valve to open when piston has not reached, let us say this is E. So E is intake valve open, this is intake valve open. So ideally we should allow that the intake valve should open when piston is exactly reaching at the TDC, but this is not the case. Before piston reaching at TDC, we are opening the intake valve, and again it is done because whenever piston is reaching towards TDC at the end of the exhaust stroke, we are allowing intake valve to open, and incoming air, we are allowing some air to come in. So that incoming air may again help to remove the combustion product, may remove the combustion product. So that is why this is done. Now note it that A and E, this is the portion where, this is the portion I am highlighting it. So A, E, this portion is known as, this is known as valve overlap. This is known as valve overlapping region. Valve overlapping region. Because this is the region where both the valves are open. Both valves are open. Right. So this is known as valve overlapping region where both valves are open. Intake is open, exhaust is open. So air is coming, little bit air is coming, and that fresh air will be allowed to combustion product to go out. Or not only that, some fresh air will be used to mix with the combustion product only to dilute that, so that the efficiency will increase. So this is what is the known as valve timing diagram. So as I said you that today our discussion was on the operating characteristics of the engine performance or engine operating characteristics. So we have started our analysis, we have started our discussion on this with this valve overlapping diagram, and then we will see how we can specify what is the work done, and then what is the mean effective pressure, which is very important to specify the total power, I mean output, and then we will discuss about what is the torque output from I mean from this diagram, and for that we need to exercise a little bit mathematical calculation. Fine. So towards up to this we have understood that whatever we have discussed in the last lecture, that the valve opening time and movement of the piston in the engine cylinder, that is not exactly the case. From that is what we can understand from today's discussion. And whatever, why we are opening and closing intake and exhaust valve when piston is exactly not at the VDC or TDC, that is what we have discussed. So with this I stop my discussion today, and I will continue our discussion in the next class. Thank you.